All right, welcome to The Explainer. Today, we're getting our hands on something pretty special. This isn't just theory, okay? We're diving into the actual blueprint, like the real deal syllabus for how you would teach someone to build a thinking, walking, honest-to-goodness humanoid robot. We're talking the full recipe, the software, the shopping list, the whole strategy.
And get this, that quote isn't from some sci-fi movie. It's the literal opening line of a brand new university course. And what it's really saying is that AI is breaking out of the data center. It's moving out of the cloud and into the real world, getting a body so it can start working right alongside us.
So this brings us to a really important idea, this new field they're calling physical AI. I mean, what is that, right? Well, it's pretty simple, actually. It's all about giving that digital brain a physical body. We're talking hands, eyes, legs, the whole deal. The goal is to let AI see, move around, and actually do stuff in our world, not just crunch numbers.
Okay, so where do you even start? If you want to build one of these things, what's the first step? Well, you might think it's all about hardware, right? Nuts and bolts. But actually, the journey begins with the mind. So let's dive in and take a look at what makes up a robot's brain.
And what's fascinating about this blueprint is that you don't just write one giant piece of code. It's not like that at all. Instead, you build the robot's mind in 3 totally separate layers. Think of it like a stack, where each layer has its own really specific job to do.
And I love how they've broken this down. It's such a great analogy, right? You've got the nervous system, which is like the wiring. Then you've got a digital playground for it to learn in safely. And finally, you have the actual AI brain. It makes so much sense when you think about it that way.
Okay, so layer 1, the nervous system. Every single robot needs one. And in the world of robotics, that's something called ROS2. It is the industry standard, basically the glue that holds everything together. It lets the robot's brain, all its sensors, and its motors communicate with each other instantly. It's the plumbing, the wiring, it's absolutely fundamental.
All right, next up is the digital playground. And this is just smart. I mean, you're not going to drop 90 grand on a robot and then just let it stumble around your lab crashing into stuff, right? No way. So instead, you build what's called a digital twin inside a physics simulator like Gazebo. In this virtual world, the robot can fall down, run into walls, and learn about gravity 1,000 times over, and it doesn't cost you a dime in repairs.
And that brings us to the top layer, the AI brain. This is where the magic really happens. We're talking about using super powerful tools like NVIDIA Isaac Sim to create these stunningly photorealistic worlds. The robot isn't just learning physics here, it's learning to see. It's training its perception, figuring out how to navigate complex spaces, all before its physical body is ever even switched on. So, we've built this amazing digital mind. It can see, it understands physics, but how do we talk to it? I mean, we're not going to be typing lines of code. The whole point is to interact with it naturally. So how do you teach a robot to understand plain English?
Well, this is where it all comes together. The blueprint lays out a really cool pipeline. You start by just speaking. You say something like, "Hey, clean the room." The robot uses a tool like OpenAI's Whisper to listen. Then a large language model figures out what clean the room actually means. And finally, it breaks that big idea down into a series of concrete steps, like pick up trash, move to bin, and sends those commands through its ROS2 nervous system to actually get it done.
Okay, so the software side of this it's just brilliant. It's this elegant, layered approach. But let's be real. A brain without a body can't do much in our world. And this is where we hit the hardware reality check. Things are about to get very real and, frankly, very expensive.
Remember those super realistic simulations? Well, to even run them, you need a monster of a computer. We're not talking about your average laptop here, no way. We're talking a top-of-the-line NVIDIA graphics card, a crazy fast CPU, and a whopping 64 gigabytes of RAM. This is serious computing power, just for the training.
And that's just for the simulation. To actually put that AI brain into something physical, students need what's called an edge kit. And you could basically think of it as a brain in a box. It's a small but powerful computer like the NVIDIA Jetson, hooked up with a camera for eyes and a microarray for ears. And that little package, that'll set you back around $700.
Okay, now for the main event, the robot body itself. And the course is pretty smart about this. It gives you 2 options. Path 1 is the budget route, using something like a robot dog as a stand-in. All the software principles are the same. Or there's Path 2, going for the real deal, a full-blown 2-legged humanoid robot.
So how much for that robot dog?
you're looking at about $3,000. Now, that's not cheap, for sure, but for university lab, it's manageable. It's in the realm of possibility.
But what about the full humanoid, the top-tier, research-grade stuff? Hold on to your hats. We're talking over $90,000. A huge jump. That's a number that basically locks out everyone except the biggest, most well-funded labs and companies.
So that $90,000 price tag, it brings up a huge critical question that the blueprint has to address. If the hardware is this expensive, how on earth do you set up a lab where you can actually teach people how to do this?
And it really comes down to a classic choice, one that businesses make all the time. Do you spend a ton of money up front, that's your capital expense, and buy all those powerful workstations and robots yourself? Or do you rent everything, use the cloud for the heavy computing and just pay as you go? That's a higher operating expense, but you don't need a huge pile of cash to get started. But here's the real kicker, and maybe the most important takeaway from this whole blueprint. Even if you go the cloud route, even if you rent all that computer power, you can't escape the physical part of physical AI. It's unavoidable. You still have to buy that $700 brain in a box for every student, and you still need at least one physical robot for them to test their code on in the real world. So the bottom line is, you can't do this purely in the cloud. There will always be a real significant hardware cost. So there you have it, the entire blueprint, from a line of code all the way to a thinking machine that can walk around in our world. We've seen the software stack, the hardware shopping list, and the pretty sobering costs. It really makes you realize the question isn't, can we build them anymore? The blueprint is right here. The real question now is, what do we want them to do first?